Okay, hi everyone. Today we are going to talk about physics, which is the topic is specific heat capacity. Okay, so before that we are going to go through this actually in the video today. The first one is that know that a rise in the temperature of an object increases its internal energy. Second, describe an increase in the temperature of an object in terms of increase in the average kinetic energies of all the particles in the object. The third one, define specific heat capacity as the energy required per unit mass per unit temperature increase. Recall and use the equation. Okay, so there's a video here where I cannot play it. So there is actually in the video there are two balloons. There is demonstration of specific capacity. So there are two balloons, one with air inside, total air inside, one with air and water inside. So they put the balloons, both the balloons, near to the light candle. So what happened after that is the balloon with the air, what have balloon with the air is burst. Okay, but the balloon with the air and water did not burst. Okay, so why? Okay, let's learn today. Okay, but before that we talk about internal energy first because it has relation with the specific heat capacity. So what is internal energy? Basically, internal energy is the sum of the total kinetic energy and potential energies of all the particles within a system. What does a system mean? A system means that when we talk about a system, we're talking about everything around us. Okay, so everything around us is matter, so solid, liquid, and gas. So anything. So let's say you have a ball. So inside a ball, that's the system of the ball. Okay, so inside a ball there's a particles. So these particles is move it is always move, right? So it vibrates. Basically it's because it's solid, it vibrates at its own position. So this one they have kinetic energy. The vibration cause kinetic energies, and also the arrangements cause potential energies for the ball itself. Okay, so the total kinetic energy and potential energy will lead to this internal energy of the ball. Okay, so basically everything around us they have their own internal energy. Okay, so what happens when you heat up the liquid? Okay, it's not specifically a liquid. Now, what happens if you heat up the system? Okay, so what happens if you heat up the system? Because just now we said that inside the system got kinetic energy and potential energy that cause the internal energy that lead to internal energy of the system. Okay, so what happens if you heat up that system? So this heat up, okay, let me show you this one first. Okay, so this is actually another video show a demonstration of when you heat up a system, but then I cannot show you the video. But you can go to the PHET website later, you can search for it and then you can try it by yourself. Okay, so this one we have a heat here. So this is when you increase the heat, what happen is you can observe that the particles is moving mm, more moving more. Okay, so what happened is because this heat they contain heat energy, they have heat energy. So this heat energy is transferred here as a kinetic energy. So just now we said that internal energy of the system is because of the kinetic energy and also potential energy. So what happens if you increase the kinetic energy? Of course, you will increase the internal energy. Okay, so heat, when you heat up a system, you will provide the heat energy. So this heat energy transferred into kinetic energy, increase the average kinetic energies of the system, will increase also the internal energy of the system. Okay, so we have a question here state that what happens to the internal energy of the water as the temperature of the water decreases. Describe the change in terms of energy of the particles. So just now we increase the heat. Okay, so when we increase the heat, we increase the heat energy transfer to the kinetic energy. Now we say that the temperature decreases. So why the temperature is decreases? Because the heat energy of the system is flow out, so it decrease the heat inside it decrease the temperature. Okay, so this one when the heat moving out of the system, what happened to the average kinetic energy? It will decrease also. So what happened when the average kinetic energy decrease? It will also decrease the internal energy. Okay, Alright, so now we're going to talk about specific heat capacity. Okay, because all of these have internal energy inside it. Okay, so basically, what is specific heat capacity? We can define specific heat capacity as the amount of energy required to raise the temperature of 1 kg of a substance by 1 degree Celsius. Okay, so we talking about specific heat capacity. So let's say you have a 1 kg of metal ball here, and then you want to increase it to from 20 degrees Celsius to 21 degrees Celsius. Okay, so let's say that the amount of energy needed is 300 joules. So this is 300 joules is needed to increase 1 degree Celsius from 20 degrees Celsius to 21 degrees Celsius of 1 kg substance is what we call it as specific heat capacity. Okay, so the amount of energy required to increase the temperature of the substance. Okay, so how do we write it? We write it as 300 joules per, the amount of 300 joules per kilogram degree Celsius. Okay, so because this is the amount of the energy needed per kilogram per degree Celsius. Okay, so you have to remember the unit, because in IGCSE they are very particular about the unit. Okay, and then you also have to be very particular because sometimes they didn't use joules, they didn't use kg or degree Celsius. Sometimes they use kilogram, they use Kelvin, and also they use a different like kilojoules. Certain they change the unit itself. So it has to depend on this. Okay, but generally speaking, the amount when we talk about the amount of energy, so this is amount of energy. So per 1 kg per degree Celsius. Okay, so it can be written like this. Okay, so but in real life, not all substances are 1 kg. Okay, some materials they are, some system they are 5 kilogram. They have their own masses. They have their own mass. Okay, so that's why sorry. So it depends on the materials itself. Okay, so let's say you have you need 500 joules of heat energy to increase the temperature by 10 degrees Celsius of 5 kg of copper ball. So how do you write these things? So you write to 500 joules, okay, per 5 kilogram and 10 degrees Celsius. So this one we can calculate it. So later we can see how how much is the specific heat capacity for these objects of 5 kg metal ball. Okay.